Chapter 7, Exercise 7.39. Consider the unbalanced equation for the combustion of heptane. Carbon 7, hydrogen 16, that's heptane. HEPTA, that's the prefix for 7. It reacts with oxygen gas to produce CO2 and water. Balance the equation. Express your answers as integers, separated by commas. When I balance a chemical equation, I usually balance one element at a time, and I also start with the most complex formula. In this case, carbon 7, hydrogen 16 is the most complex formula. And usually I set the coefficient for the most complex formula to be 1. Alright, so alpha is just 1, and then beta, I'll put a question mark here because I don't know what beta is. It does not allow me to enter question mark, so I'm gonna use a pound sign for beta. I don't know what that is. Gamma, somehow I know the value of gamma because again, let's balance one element at a time. On the left hand side, we see carbon appears in heptane but not in oxygen. If I have one heptane, it contains 7 carbon atoms. Therefore, on the right hand side of the equation, I need 7 carbon atoms. Therefore, this gamma has to be 7. Alright, and then I put another pound sign here, to be determined. Now let's look at hydrogen. On the left hand side of the equation, I have carbon 7, hydrogen 16, and also O2. O2 does not contain hydrogen atoms, so it's just here in heptane. When alpha is 1, we have 16 hydrogen atoms. Therefore, on the right hand side of the equation, we need 16 hydrogen atoms. And there's no hydrogen in CO2, so we have to have 8 water molecules. Alright, 8 water molecules contain 16 hydrogen atoms. Now we balanced carbon, we balanced hydrogen. Finally, oxygen. We need the value of beta, so we know this gamma is 7. 7 times 2, we have 14 oxygen atoms in CO2, and also we have 8 oxygen atoms in this 8 water molecules. So 7 and 8, 7 times 2, that's 14, plus 8, that's 22. Therefore, we have a total of 22 oxygen atoms on the right. We need also 22 oxygen atoms on the left. Therefore, beta has to be 11. Now let's check. Those are integers and they do not have any common factor, so we'll just submit our answers. Okay. Determine how many moles of O2 are required to react completely with 4.8 moles of heptane, carbon 7, hydrogen 16. So if we have 4.8 moles of heptane, how many moles of O2 do we need? You can see alpha and beta are 1 and 11. So the number of moles of O2 is 11 times the number of moles of heptane. We have 4.8 moles of heptane times 11. That will be the answer. Let me just try this and see if it works. Okay, it works. 4.8 times 11 is 52.8, and then it's rounded to two figures, 53.